Okay, hello everyone. My name is Isabella Jaramillo. I am the field intern for Oceana and I'm based in Washington, D.C. And today we have another segment of our Keep Our Ocean Fishy, Ocean Steward Spotlight. And today we have the extreme honor of having Dr. Shima Abadi, a professor of oceanography, electrical and computer engineering, and engineering and mathematics at the University of Washington. Her research focuses on ocean noise, including sound source localization, acoustical imaging, and animal bioacoustics. Dr. Abadi has received 2 awards from the Acoustical Society of America. She is currently working on mitigating seismic airgun blasting noise, analyzing ocean ambient noise, and developing algorithms for analyzing data collected by large underwater networks. Thank you so much for being here with us today.
Thank you so much for inviting me.
So I'm just going to go ahead and start with the questions. So my first question for you is, when and where did you fall in love with the ocean?
So I should just start from maybe the first year of my PhD. I actually fell in love with the math involved in ocean acoustics. And then later I realized that I love working in the ocean too. So I was the first year PhD student looking for a research project for my thesis. And I was talking to a professor, which later became my PhD advisor. And he was talking about the research that he was doing with underwater acoustics. And so basically, when he was talking about the research, I realized that the math involved in ocean acoustics is exactly the type of math that I would love to work on. I mean, I'd love to work on not just pure math, but applied mathematics. Like, I would love to solve partial differential equations, boundary conditions, and that's all we do in acoustics. Basically, we solve the wave equation. It's another layer of complexity in the ocean is that the speed of sound is not constant. So the coefficient that we have in the wave equation are not constant, like a speed of sound and density. In air, we can assume speed of sound is just constant, but in ocean, that's not true. I mean, we have layers with different properties, and that will make the whole acoustic propagation problem very complex. So I fell in love with the math. And then when I was working on that problem and research topic, I just realized how amazing the ocean environment is. And then later I kind of like kept working in the same area. So that goes back to 2008. It's the first time that I started working in this area.
That's wonderful. I'm in grad school right now, and I can't say that I like the math behind it, but that's really awesome to hear how passionate you are. So my next question for you is, as I'm sure you know, Oceana and our partners have worked on a successful campaign to halt seismic blasting to search for oil and gas in the Atlantic. Can you explain to our audience what air guns are, what they're used for, and just as a whole, what is this whole process?
Sure. So airguns are a type of loud acoustic sources that women, I'm sorry, let me just mute myself. I'm sorry about that. So we use in the ocean to map the ocean floor. And most of the time it's used by oil and gas companies to find oil and gas, or a lot of times researchers in research community use that for understanding what is going on beneath the seafloor, I mean, deeper layers. You know, like what is causing earthquakes, for example, and learning about geophysics, basically. So air guns are a huge amount of air that are compressed, and then we suddenly release that amount of air into the ocean downward. And by releasing that, we generate bubbles in the ocean, and those bubbles oscillate and generate signal. And the signal that they generate is pretty much at lower frequency range, something between 20 up to 200. That's the main frequency range, but it also goes up to higher frequency as well. And air guns are repetitive. We need to shoot very often. You know, the duration can vary between 20 seconds or so. And that can go for couple of weeks or a couple of months, depends on the survey, the type of the survey. It's a loud signal, it's a very loud signal, and because the frequency range of air guns are at the same frequency range of a lot of baleen whales, it's concerning because first, those signals may mask any passive acoustic monitoring that we may have at the survey. And second is, those signals may have long-term and short-term impacts on baleen whales. And a lot of baleen whales are in the endangered species category, so we should be careful when we do this type of experiments.
Wonderful, thank you. So naturally, my next question is, can you tell us a little bit about the work that you do to mitigate seismic airgun noise? And are there any safer alternatives in your opinion?
So what I do is kind of like work in the both area, like I mentioned, masking and impact, basically. So I try to find new methods for finding the location of marine mammals around the seismic surveys for monitoring purposes, because based on the regulation, we have to have monitoring going on at the survey, but there are some challenges involved. So if you have visual monitoring, we only see animals when they are at the surface, and they are not all the time at the surface. The only issue with that is that we cannot see animals at night or when the weather is bad. We can use passive acoustic monitoring for that, but for doing passive acoustic monitoring, animals should be calling, they should be vocalizing in order to be detected. That doesn't happen all the time. Like a lot of times only male animals call or vocalize, or a lot of times they are quiet. I mean, the studies have shown that the calling rate may change when they're exposed to loud airgun signals. So there are some challenges involving each category. What I do is try to find new algorithms that we can find a location of animals using passive acoustic monitoring. I also look at how airgun signals propagate in the ocean. And that's important because when the sound propagates, the pressure level decreases as we go further from the source. But it's not an easy calculation because it depends on the environment, it depends on the bathymetry, it depends on bottom properties, it depends on a lot of things, the type of airgun array that we use. So we need to know how far from the airgun the pressure level decreases to what is called the safe pressure level for animals. That helps us for monitoring, so we know if the animals get closer from to the airgun from that safe radius that we calculate, then we need to power down the experiment or shut down the experiment.
Wonderful. So my next question is for our viewers who want to take action. What would you say to people who love the ocean but don't really know what steps to take to protect it?
Well, ocean is big. I mean, it's 70% of our planet. There are so many things we can do, and ocean is doing a lot of things for us too. So one thing that we can do, first we need to educate ourselves to learn about the processes in the ocean and how those processes impact our life in our, all the animals' life, basically. We should educate ourselves, and when we do that, we can take actions. And global warming is a big issue that is, there are so many talks in the news every day about that, but it's really impacting the ocean, and not just the ocean environment, but also marine mammals in the ocean environment. So marine mammals are, they have learned what's the optimum depth, for example, that they can swim and vocalize, and all their life functions depend on vocalization. So they do mating by vocalization, they find food by localization, they do navigation by vocalization. So it's very important for them to find out what's the optimum depth that they can send their signal to the whatever they're doing. But over time, when the environment changes, they learn how to adapt. But with global warming, the changes are so fast and they cannot learn. So something that happening in the Arctic area, for example, when we get more ice melting, we get more fresh water coming into the ocean to the top layer. That changes the speed of sound profile, and it will change the depth that basically the depth of what is called SOFAR channel, basically the channel in the ocean that a signal can propagate long distances. And animals are struggling to find that depth because the change is so rapidly. So anything that we can do to slow down global warming would eventually help the ocean and help the marine mammal in the ocean.
Thank you. So we do have two major audiences that tune into these webinars, and they're split into people who are getting into their conservation values and those who have years and careers in this. This question is for the ocean community already at work, very deep into their careers. What is your vision for ocean conservation for the community as a whole?
So we started thinking about the impact of our activity, human activity in the ocean, in the past 50 years or 60 years or so. The research is going on. We are getting more interest, more focus on this, and people are spending more time understanding the impact of human impact on the ocean and the footprint of human in the ocean. And so the research is going on. My vision is that, and also we are getting really good at hardware in like equipment development. We're getting hardware that are able to collect data for a long period of time without disturbing the environment much. So as we get more data from the ocean and we learn how to analyze big data, we can understand the ocean as a whole system, and not just by looking at a few hours of recording, for example, at very tiny location in the ocean. We can collect data from multiple locations at the same time, long-term period, and understand the processes in the ocean better. And then hopefully we can later change how the regulations are, so we can impact that area to have a better planet to live.
Just following up on that, do you believe there should be new approaches that we should be focusing on some more? Should there be like a new direction? What should we do specifically to make sure that all of the research that we're getting is used into positive legislation?
The new direction is already happening, actually. We are getting more data, and we are using more data science skills and tools to analyze that big data. And it's already happening. We are just at the beginning of that. The hardware development is more advanced than software development. So we are good at collecting data, but not that much good in terms of analyzing data, but we are getting to that point. As we collect more data and we analyze more big data in the ocean, we can proceed in terms of convincing policymakers that this is the right decision that they need to take.
Gotcha. Well, thank you so much. I have a few questions a little bit lighter, just so our audience can get to know you a little bit more. What is one ocean area that you have always wanted to visit the most?
That's a tough question. They're all very beautiful. I mean, deep ocean in general, I would say. Deep ocean is fascinating to me. I mean, how deep the ocean is and how the physics is changing or dealing with this environment, and then, how important it is for us basically to understand the physics and mathematics in order to learn from deep ocean. And we are usually far from deep ocean. We don't live there. We're not close to there. So there are still so many things that we need to learn. So I would love to visit deep ocean.
And on that note, what is your favorite sea creature?
I love marine mammals in general, and maybe my favorite species is humpback whale, because they sing beautifully. I mean, if you just listen to their vocalizations, it's very beautiful. I mean, you can just listen to them. I mean, before going to bed, it's so relaxing.
Wonderful. So there's only so much time that we have with you. And our time is coming to an end, but we want to make sure that we can share with our audiences how to find out more about you and your work. We'll throw up info on the screen now before people go so they can learn more or make a donation. Here it is for everyone. Before we sign off, are there any parting words for the people watching?
No, I think your audience are here. That's the biggest step that they've already taken to save the ocean, save the planet. I mean, that's it. You're wonderful to be here, and I hope that at some point. So right now we don't know much about the ocean. We know much about other planets than our own ocean. So at some point we learn about our ocean, and maybe by knowing more about the ocean, we can save the Earth in general.
Thank you so much, Dr. Abadi. It was a pleasure speaking with you. And thank you everyone for tuning in. Stay tuned, monitor our Facebooks for more information on our next segment.
Thank you so much.